Now the next question for, I'm assuming the same utility function which I had, maximizing the utility function which is x1 minus r to the power alpha, x2 to the power beta, subject to p1 x1 plus p2 x2 is equal to m. I have to maximize the same utility function, but now what's the question that I have in mind? The question that is given to you is solve for x1 star, x2 star as a function of p1, p2, m and r1. And now it says you don't have to check the second order condition, you just have to solve this. Okay, so what we can do is very simple. I already have solved for the first order conditions in the previous video. I have already found out using Lagrange what my first order conditions are. So, from this, I'm just going to go ahead and divide equation 1 by equation 2. Refer to the previous video. So, dividing equation 1 by 2, what do I get? From when I differentiated it with respect to x1, I was getting this. So I was getting alpha x2 to the power beta upon x1 to the power 1 minus alpha x1 minus r to the power 1 minus alpha, and I was getting that equal to lambda p1 is equal to lambda. And if I divide this by the other equation, this is beta x1 minus r1 to the power alpha x2 to the power 1 minus beta, and if I divide this side, I get p2 lambda. This is what I'm getting. Okay. Now just remember, whenever you divide, whatever comes in the denominator, if you're dividing that, then you're just multiplying it with the reciprocal of that. So let's just rewrite this. Let's rewrite this, and what do I get by rewriting? So I get alpha x2 to the power beta upon x1 minus r to the power 1 minus alpha into, I will, reciprocate this. So x2 to the power 1 minus beta upon beta into x1 minus r1 to the power alpha, and this gives me p1 by p2. These first order conditions were derived in the last video. Please refer to that and the last to last video from where we had started forming the Lagrange. Now, when base are same, power gets added. So I have alpha into x2 upon beta into x1 minus r1 is equal to p1 by p2. Or I get x2 is equal to p1 by p2 into beta by alpha into x1 minus r. This is the value of x2. I know from my third equation that p1 x1 plus p2 x2 is equal to m. Instead of x2, I will substitute x2 star that I just found out. This, just substitute this value. Okay, so if you substitute it, what do you get? You have p1 x1 plus p2 x2 is equal to m. Instead of x2, I will write down what I just derived. Is equal to m. So my p2 and p2 gets cancelled out. p1 x1 plus p1 beta by alpha x1 minus r1 is equal to m. So let's solve this further then. I can take alpha, I can take P1 X1 common. Let me just rewrite this. So I get P1 X1 plus P1 into beta by alpha into X1 minus P1 into beta by alpha into R1 is equal to M. Okay. Now from here, just notice what I'm doing. From here, I'm going to take P1 X1 common. So I get P1 X1 1 plus beta by alpha is equal to M plus P1 into R1 into beta by alpha. Okay. So now I'm going to solve for X1 star. X1 star would be, so what I can do here is I can just use the property that was given to me in the question, that so it was given to me, given that alpha plus beta is 1. This was given to me. Okay. If you refer to the first part of this question, it was given to me that alpha plus beta is 1. So what I'm going to do is I'm going to solve this. But before I solve this, I am going to just write this again. So I'm going to write P1 X1 alpha plus beta by alpha is equal to M plus P1 R1 into beta by alpha. And I'm going to take this part as 1. Okay. So I will have X1 star then as M alpha plus P1 into R1 into beta upon P1. So this will be alpha into M by P1 plus R into beta. Beta can also be rewritten because alpha plus beta is 1. So if I just want to write everything in terms of alpha, instead of beta, I can write 1 minus alpha. So I can rewrite this as alpha into M by P1 plus R1 into 1 minus alpha. This is also another way of writing it out. So finally, what I get here by solving is the following. I get X1 star is equal to alpha M by P1 plus 1 minus alpha R1. Okay. Now, once I've solved for this, I'm going to solve for X2. So I know that X2 I had given as this. P1 by P2, beta by alpha, X1 minus R1. So I'm going to write this down. P1 by P2, beta by alpha, X1 minus R1. So this will be P1 by P2 into beta by alpha into alpha M by P1. So plus 1 minus alpha R1 minus R1. Okay. So I can solve for this. And now what I'm going to do is I can also go ahead and, instead of beta, I can write 1 minus alpha to solve it easily if I want to. So what I can also do now is solve for this like this. So this will be P1 by P2 into beta into M by P1 plus. So what I've done is the following. I have multiplied this part with this part first. So my alpha and alpha gets cancelled and I'm left up with this part plus P1 by P2 into beta by alpha. I'm going to take R1 common from here, 1 minus alpha minus 1. Does this make sense? From here I've taken R1 common. So if I take R1 common, then here inside I'll be left up with minus alpha. Okay. and I can cancel this out, and I'll be left up with -1. So just try and solve this out. You'll be left up with -1. So you will have P1 by P2 into beta into M by P1 minus P1 by P2 into beta into R1. Now, P1 and P1 of course gets cancelled out from here. So you'll be left up with beta into M by P2 minus P1 by P2 into beta into R1. This is the, and you know what you can also do is write it like this. So instead of beta, I can take beta common. If I take beta common, I'm going to get, and I'll get M by P2 minus P1 by P2 into R1. And instead of beta, I can actually write this as 1 minus alpha, so that I have both x1 and x2 in terms of alpha. So 1 minus alpha, I can also take P2 common, and I'll be left up with M minus P1 R1. Okay, I will also interpret this shortly in the next video. But for now, what you can do is the following. And you can now solve for lambda also, okay? You can solve for lambda. But what is important here is the following. I wanted to find out x1 star and x2 star, and I have got my x1 star as alpha into M by P1 plus 1 minus alpha into R1, and I've got my x2 star. I'm just writing everything in terms of alpha. I know alpha plus beta is 1. So I've got my x2 star as 1 minus alpha by P2 M minus R1 into P1. I will stop this for now. I'll stop this here, but we are going to also kind of try and interpret these equations. So for now, you should understand how to find x1 star and x2 star, how to form Lagrange, how to differentiate Lagrange with respect to x1, x2, lambda, and how to solve these equations further to get x1 star and x2 star. Okay, thank you.